I'm your host, Mark Spagnuolo, and today we're going to learn about one of the most important joints in woodworking, the mortise and tenon. Now, the mortise and tenon joint is one of the strongest joints in woodworking, and it's a joint that you should probably master if you want to make high-quality furniture. Now, chairs, tables, doors, cabinets, and tons of other pieces will all benefit from the strength of a mortise and tenon joint. And if you ever plan on making something in the mission style, well, you better get ready to become intimately familiar with this joint. Check out this mission style entertainment center that I built a few years ago. If you could believe it, that sucker required 82 mortise and tenon joints. So what is a mortise and tenon joint? Well, for anyone who might not know, this is a mortise and this is a tenon. Now, the tenon fits nice and snug into the mortise, creating a really tight and secure joint. Now, why is a mortise and tenon such a strong joint? Well, the simple fact that we're inserting one part of a board into another board gives the joint a lot of strength. And in addition, this joint creates a significant amount of long grain to long grain glue surface, which is really the best case scenario when using wood glue. Now, before going into detail on mortise and tenons, let's quickly take a look at some alternatives that you might be tempted to try. Now, first, there's nothing. You can actually try to do a simple butt joint like this. But it's never really a good idea since the end grain always sucks up the glue and leaves us with a glue-starved joint. And that's not good for anybody. Next, you might consider using biscuits. Now, this is a biscuit joiner, and this is a little biscuit. Now, biscuits are certainly a step up from a simple butt joint. They're easy to make, and they keep the boards aligned really nicely. But they don't really bring a significant amount of strength into the mix. These little guys just don't penetrate deep enough. Another option might be dowels. 2 dowels would provide a pretty strong joint. In fact, strong enough for most applications. Now, they're easy to set up, they don't require anything more than a drill bit and some patience, although there are numerous jigs on the market that will help you get consistent placement of your dowels. Another good option would be pocket screws. Any pocket screw fans out there? Yeah, I thought so. Now, pocket screw technology is just a fancy way of saying held together with screws. The screws are driven at a very shallow angle and do a great job of holding 2 pieces together. It's quick, it's easy, and if you don't mind screws, it's a great option. But you'll have these screw holes to contend with in the back. Now, they do make wood plugs for these holes, but if I have to go through that much trouble, then I pretty much negated any time savings. Now, there is one last alternative, but I'm going to save that surprise for a little bit later. I promise you, though, it's going to be fess cool. Before we go any further, let's get some terminology out of the way. Now, this area here that runs parallel with the face of the board, that's known as the cheek. Okay, the lip that surrounds the actual tenon all the way around the board, that's known as the shoulder. So what do we start with first, the mortise or the tenon? And personally, I prefer to cut my mortises first. The primary reason for this is that the mortise is cut by something that's a constant size, either a router bit or a hollow chisel mortising bit, and it can be tricky to make the necessary fine adjustments to match that up to a tenon. Now, the way a tenon is made, on the other hand, allows for exact measurements and slight adjustments, so we can really sneak up on the measurement by cutting a little bit at a time and test fitting. As a rule of thumb, tenons should be made about 1/2 the thickness of the board. So in the case of a 3/4 inch piece of wood, the tenon should be made about 3/8 of an inch thick. Now, the rule of thumb for tenon length should be about 4 to 5 times the thickness of the tenon. Again, for a 3/4 inch thick workpiece with a 3/8 inch tenon, the length would be between 1.5 and 1 7/8 inches long. And this measurement also depends greatly on the piece that we're gluing our tenon into. There are a number of ways to make a mortise. Now, this is pretty much the way that it used to be done. You could even use a drill press and a force-through bit to hog out most of the material and chisel away the rest. Well, I could use my feet to go down the road like Fred Flintstone in my car if I wanted to, but sometimes you just need to take advantage of technology. Now, I find that when it comes to making a mortise and tenon joint, power tools are the fastest and most accurate way to go. That doesn't mean that you shouldn't learn to do this process with hand tools. In fact, practicing some of these classic techniques is a great way to improve your manual dexterity and confidence with hand tools. Most of you probably own a router, so this particular method is likely to be the most feasible option for you. Now, I prefer to use an up spiral straight bit for creating my mortises. An up spiral bit gives us more efficient cut because it pushes the wood chips up and out of the hole. The disadvantage is that the up spiral bit may also tear out some of the wood fibers near the top of the mortise. But with a good sharp bit, this usually isn't a problem. And even if there is a little bit of tear out, it'll most likely be covered by the shoulder of the tenon. Now you can use a down spiral bit if you have one, but they're better suited for shallow holes. Now I actually need to get a new up spiral bit, so I'm going to use my standard straight bit for now. Alright, let's set up for our mortise cut.
I begin by attaching an edge guide to the router base. Using double stick tape, I attach a second board to the mortise board. This gives my rounder the extra support that it needs to stay balanced and safe. I then clamp the boards between two dogs on my workbench. After marking the location of the mortise using a pencil and a straight edge, I carefully set the straight bit right to the pencil line. After bringing the bit down to the surface of the wood, I use the built-in depth gauge and stop to set the plunge depth. With safety gear on and the dust extractor attached, it's time to start routing. Now if the depth of the mortise is greater than 3/4 of an inch, you may want to consider making the cut in 2 passes.
Now when you're done, you should have a nice, smooth-walled mortise. Now you'll notice that I didn't use stop blocks, I simply routed to my lines. This makes the setup go a little bit faster, and if I go over the line by a 32nd of an inch, it really isn't going to make all that much difference. The joint's going to be just as stable. And one other thing to note is the fact that the mortise now has round edges. That means that we'll either have to round over the edges of our tenon later, or we can square up the corners of the mortise with a chisel right now. I prefer to round over the tenon, call me lazy. Now I'd also like to mention that you can certainly use your router table to make a mortise, but that usually requires slowly dropping the workpiece onto a moving router bit, which is not exactly my favorite thing to do. So if you can avoid it, you're probably better off taking the tool to the wood rather than the other way around. Ever wonder if you could drill a square hole? Well, with this machine you can. This is a hollow chisel mortiser, and you can find these for, I would say, as little as $200 and probably even cheaper if you find a used one. It is a one-trick pony, but when that pony's trick is an essential woodworking task like making mortises, it's really a good investment. Now this machine uses a special boring bit that's housed inside of a 4-sided chisel. Now as the bit hogs out the bulk of the material, the chisel slices the hole into a nice even square. Let's do a sample cut.
Setting up the mortiser is easy. With a pair of gloves on, I insert the bit and the chisel, keeping the chisel about 1/8 of an inch from the top. I then tighten the chisel and the bit into place. Once the bit is secure, I raise the chisel to the top. This technique results in the bit protruding just ahead of the chisel, which results in a much more efficient cut. Placing a piece of scrap against the fence, I rotate the chisel so that it's square with the fence and the open end of the chisel faces either to the left or to the right. This allows the wood chips to exit the hole, reducing friction and reducing heat. Using a mortiser is a lot like using a drill press, but it requires a lot more pressure. In fact, most people are quite surprised by just how much force it takes to plunge the chisel through the wood. If you've noticed my bulging biceps in previous episodes, now you know why. Seriously though, I actually broke the ball joint on my mortiser once simply because I put way too much pressure on it. The culprit? A dull chisel. So a word to the wise, keep your chisel sharp using a cone-shaped diamond stone. Now today I'm using alder, so it cuts like butter.
Now let's talk about tenons. Of course, just like with the mortise, you could use a saw, some chisels, and do this by hand. But for all the same reasons, I prefer power tool methods. Now my favorite methods all involve the use of the table saw. And many of these cuts could be accomplished on the bandsaw as well, but I find that the table saw produces a smoother, more accurate cut. The fastest way that I know to make a tenon is to use a Dado Blade. This is a special stack of blades that allow you to adjust to any size you need using these chippers and some magnetic shims. And just make sure the arbor of your table saw is long enough to accommodate the extra blades.
Switching to a Dado blade is simple. I remove the zero clearance insert and remove the splitter. Next, I loosen the arbor nut using a piece of scrap to immobilize the blade. I assemble the Dado blade with several chippers between the outer blades. The final width is about 1 inch. When tightening the arbor nut, I find that most people tighten way too much. I usually secure the blade with my fingers, put the wrench on the nut, and give the wrench a few taps with a piece of scrap wood. As soon as the blade feels like it's going to slip out of your hand, it's tight enough.
Now we've got our Dado blade installed. Notice that I have to remove the splitter in this case, number one, because the insert that I use with my Dado blade doesn't have a space for my splitter. And secondly, more importantly, we need to pass this over the blade without making a through cut, which would actually cause a major problem if we hit the splitter. After I mark the cut lines for my tenon, I like to set the fence up as a stop. Now this will allow me to batch out as many tenons as I need, and they'll all be exactly the same. Now there's a potential safety issue here though. If I use the fence as a stop, we could have a kickback when the workpiece is over the blade and wedged between the blade and the fence. And that's when I use my little handy auxiliary stop. It's shop made of 3 pieces of plywood and a couple of bolts. Now as long as the stop is in position before the blade, the workpiece will be properly indexed for each cut without the danger of being wedged between the blade and the fence.
Using my adjustable square, I mark the location of the tenon shoulder. I don't adjust the blade to the final height on the first shot. I like to do a few test cuts on the tip of the tenon. This way, if I go too far, I still have the rest of the tenon to correct the error. After a quick test fit, we can see that we need to remove quite a bit more material. Test fit number 2 shows that the tenon's just a bit too big. I raise the blade just a little bit and take another cut on both sides. Yeah, who's the man? With the fence adjusted and the blade set at the perfect height, it's time to cut the entire tenon. I usually cut the tenon in about 4 to 5 passes, and then flip it over and do the other side. Using the same methods as before, cut the sides of the tenon if necessary. And that, my friends, is a tight-fitting tenon. If the tenon fits too tight, a light touch with sandpaper usually does the trick. Although it doesn't do me any good now, a piece of scrap wood double-stick taped to the miter fence will help prevent tear out.
Now you could do this same operation with your standard blade. You just nibble away the material a little bit at a time. This is okay if you have 1 or 2 tenons to make, but if you got a whole bunch, it's a tedious process and the resulting cut's usually a little bit less than ideal. Now the next method requires the use of a special jig known as a tenoning jig. Now, you could pick up one of these for about 60 bucks. The basic idea here is to hold the workpiece in a perfectly vertical position while passing it safely over the blade. The resulting cut is extremely smooth and accurate, and with the micro adjustments here, you can easily dial in the perfect cut. Time for an equipment check. Tenoning jig. Check. Eye protection. Check. Piece of wood. Check. SpongeBob pencil. Check. That's how I roll.
After marking the location of the tenon shoulder, as well as the tenon's profile on the end grain, I adjust the fence to my pencil line. I then adjust the blade height just a hair under my other pencil line. I then cut a single kerf on both face sides of the board. I adjust the blade height one more time to cut the sides of the tenon. This time, I'll take repeated passes until all the material is removed. It's just easier to finalize this dimension right now. Before using the tenoning jig, I always make sure that the side and back stops are square. And using my kerf cuts as a guide, I adjust the blade height in preparation for the jig. While holding the workpiece tight against the back and side surfaces, I use the built-in clamp to secure the workpiece. I then use the jig's micro adjustment feature to make sure that the blade is about a 1/16 of an inch away from my pencil line. With the workpiece secure, we can make our cuts. Be sure to wave at the cutoff piece as it flies harmlessly past your right hip. After several rounds of cutting and test fitting, we now have the perfect tenon.
Now it may seem like I'm adding steps by not aiming for my pencil line on the first shot, but believe me, your work will be far more accurate if you use this relative dimensioning method. In fact, I use relative dimensioning on every project and for every type of joinery that I do. I'll go into more detail on relative dimensioning in a future episode. Now, everything we've done so far is a variation of what's known as an integral tenon, where the tenon is actually part of the workpiece. An alternative to this method is known as a loose tenon. It's a joinery method where you create a mortise in both workpieces and join them together with a separate piece of wood that serves as our tenon. It's kind of like a really strong biscuit. This is a perfectly viable option, and it actually can be just as strong as a standard mortise and tenon joint. One big advantage here is the fact that the tenon stock is going to be milled from one long piece of material, so it'll all be exactly the same and you can make a bunch of tenons in one shot. And if you use a router bit that's perfectly sized for a piece of plywood, you can cut all of your tenon stock from sheets of ply. Can't get any easier than that. Now, one big disadvantage is that it's difficult to create mortises in the ends of very long pieces, like table aprons. I'm ready! Now keep in mind that if your mortise has rounded ends, like it will if you use the router, you might need to round over the corners of your tenon. You could do this with a chisel, a rasp, or even a sharp utility blade. Now sometimes you put the tenon into the mortise and you see that there's actually a little bit of a gap. You can't really get it to seat properly. So either your tenon's too long, which is an easy fix, you just trim it down, or you might need to relieve some of the material here on the shoulder, between the edge of the shoulder and where the shoulder meets the tenon. And what you want to really do is kind of, just with a chisel, create a little bit of a concave shape there, so that really the only thing touching the next workpiece where the mortise is this outside rim. It's not going to affect the strength of the joint because all the strength is in long grain glue joint. So just make that concave and that should give you a perfect fit.